Starting from this lecture onwards, we'll still focus on improving our programming by solving more problems, but this time the problem statements will be a little more challenging. The very first one here will be to find the factorial of a number. If you don't remember factorials, let me quickly refresh your memory. The factorial of the number 5 is basically 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, which is equal to 120. Here is a hint to help you solve this problem. The factorial of a number is basically the multiplication of all numbers starting from 1 up to the number itself. So you can use a for loop for this. Start at 1, go up to the number, and at every step multiply and store the result in a variable. Factorials are only for integers, that's pretty obvious, except an integer as an input from the user. Initialize the factorial variable to 1. Hopefully you've taken my advice and used a for loop for this solution. However, I'm going to implement the solution using a while loop, which is a little more difficult, just a tad bit. This factorial variable that I've initialized to 1 will store the final result, the factorial. I'm going to iterate through the for loop so long as the num variable holds a value greater than 0. For every iteration, I'm going to store the result in factorial. I'm multiplying factorial by num and storing the result in factorial itself. This is the multiplication equal to. For every loop iteration, I'm going to decrement the value of num by 1. Let's take an example and see how this works out. Let's say that we wanted to find the factorial of the number 4, that is 4 multiplied by 3 multiplied by 2 multiplied by 1. In the very first iteration, the value of the num variable is equal to 4 and the value of the factorial variable is 1. When the statements in the while loop are executed, the new value stored in the factorial variable will be 1 multiplied by 4, which is equal to 4, and the new value for the num variable will be equal to 3. This is at the end of iteration 1. The value of num is 3, which is still greater than 0. We enter iteration 2. Here, the value of factorial is 4 and num is 3. When we enter the iteration, we then multiply 4 by 3 to get the new value of factorial, which is 12, and the new value of num is 3 minus 1 equal to 2. This is at the end of iteration 2. At the beginning of the third iteration, the value of factorial is 12, the value of num is 2. We then calculate a new value for factorial, 12 multiplied by 2, which gives us 24. We then decrement the value of num by 1. So num is 1. At the end of iteration 3, factorial is equal to 24 and num is equal to 1. At the beginning of iteration 4, the value of factorial is 24. The value of num is equal to 1. We calculate a new value for factorial. Factorial is now 24 multiplied by 1, which is equal to 24. We decrement num by 1. 1 minus 1 is equal to 0. So at the end of iteration 4, we have a factorial value of 24 and a num value of 0. We now go back to the beginning of the while loop. The while loop condition basically says num should be greater than 0. The value of num at this point in time is 0. The condition evaluates to false. We exit from our while loop, and the value of factorial that we have now is the final value. Let's test out our code. We enter a number that is 5, and 5 factorial has been correctly calculated as 120. You can work this out on a piece of paper and you'll see that this is right. And here is our next programming challenge. Given a number, we want to find and print all of its factors. Now, if you don't remember what factors are from high school math, the factors of the number 10 are 1, 2, 5, and 10. 10 is perfectly divisible by all of its factors. We want to find all numbers less than 10 such that 10 is perfectly divisible by them. We want to do this for any number. That's our program. Here is a hint that will help you solve this problem. Now, the factors of a number are less than or equal to that number. So you can start iterating from the number 1 and go up to the number itself. For every number during your iteration, check whether the input number is divisible by this factor. If yes, then that's a factor, and then print that out to screen. Let's start off by accepting an integer as an input from the user. We do this in the usual way. I'm going to calculate the factors of a number by using a while loop. While loops are trickier than for loops, which is why it's better for you to have more practice with while loops. That's why my solutions tend to use while loops rather than the for loops. Initialize the factor variable to 1. We start by finding factors from 1. And here is the while loop that finds the factors of a number. So long as the factor is less than or equal to the number itself, we iterate through the while loop. There are no factors which are greater than the number itself. Let's assume that the number you input is 10. We want to find all factors of 10. The factor variable has been initialized to 1 when we first enter this loop. We'll first check the while condition. Factor is less than equal to num, 1 is less than equal to 10. We enter the while loop. Within this while loop, the if statement will check whether our number, which is 10, is perfectly divisible by 1. Yes, indeed, all numbers are perfectly divisible by 1, which is why 1 is a factor. We print out 1 to screen and then we increase the factor variable by 1. We increment by 1. The factor variable is now 2. At the start of the next loop iteration, the value of factor is equal to 2. Our if statement will check whether 10 is perfectly divisible by 2. Yes, indeed, 10 modulo 2 is equal to 0, which is why we print out 2 and we increment factor by 1. Factor is now equal to 3. When we enter the next loop iteration, factor is equal to 3, the if statement will check whether 10 is perfectly divisible by 3. 10 modulo 3 is not equal to 0, which means 3 is not a factor of 10. So we don't print out the factor. We move on to the next iteration. We increment factor by 1 equal to 4. The same case with the next iteration as well. 10 is not perfectly divisible by 4. We don't print that out to screen. 4 is not a factorial of 10. We move on, increment factor by 1. Factor is now 5. In the next iteration, we check whether our number 10 is divisible by factor which is equal to 5. Yes, indeed it is. 10 modulo 5 is equal to 0. We print out 5 to screen. We increment factor by 1. Factor is now 6. And really, this goes on. The numbers 6, 7, 8, 9 are not factors of 10. 10 is not perfectly divisible by these numbers. We'll skip over all of these till finally 10 is divisible by 10. When the value of factor is incremented to 11 using factor is equal to factor plus 1, that's when we break out of the loop because our while condition factor less than equal to num no longer holds true. Let's execute this bit of code. We enter a number 20 and here are all the factors of 20, 1, 2, 4, 5, 10 and 20. In the next example, I'm going to implement the same factor code once again, but this time we'll do a more optimized version. We'll optimize the number of iterations that we take to find all factors. Now, if you think about the math behind factors, you realize that the factors of a number are 1 and the number itself, and all other factors actually exist in the range 1 up to num divided by 2. 2 is the smallest factor after 1. You won't find any factors in the range num divided by 2 up till num. This requires some knowledge of high school math. Just think about this and you'll find that this is indeed the case. So we'll set up our while loop to include this. We'll go from 1 up till num divided by 2 and no further. We've reduced the number of loop iterations by half, which is decently significant. The while condition checks that factor is less than equal to num by 2. The remaining statements in the while loop remain exactly the same. At every step, we increment factor by 1, and at the final step, we have to print out the number itself because every number is a factor of itself. Let's execute this program. We enter a number 40, and here are all the factors of 40. Notice that there are no factors between 20 and 40. Here is a common problem that you might be asked to solve when you go for programming or analyst interviews. Find whether a number that the user input is prime or not. This is the problem that we're going to solve now. And the hint for this problem statement follows from all the discussions on factors that we've had so far. We know that a number is considered prime if the only factors for that number are the number 1, and the number itself. If it has no other factors, then the number is prime. Use this to find your prime number. We first accept an integer from the user as the input. There's nothing new here. We then initialize the factor variable to 1, exactly like before. We initialize another variable, which is a Boolean flag, which keeps track of whether the current number is prime or not. We initialize this variable to true. That is, we assume all numbers are prime until we've proven otherwise. The conditional expression for our while loop is the same as the conditional expression that we use to find factors. What we're essentially doing here is checking whether the input number has any factors other than 1 and the number itself. So long as the factor variable is less than num by 2, we increment the factor variable by 1. We increment the factor variable by 1 at the very beginning of the loop because we do not want to consider factor equal to 1. We want to start with the number 2. If we find a factor where the input number is perfectly divisible by the factor, when num modulo factor is equal to 0, then clearly the number is not prime. It is divisible by some other number. We set the flag prime is equal to false and we break out of this while loop. There is no need to check further. We know for sure the number is not prime. The number needs to have just one factor other than 1 and the number itself, and that number is not prime. Which is why if the if condition is true, we break out of our while loop, and then once outside the while loop, we check the prime flag. If the prime variable is still true, remember that's what we initialized it to at the very beginning, then the number is prime. In all other cases, the number is not prime. You can try this code with a number of different inputs to prove that it works. I'm just going to demo one input here. I'll enter 21. 21 is clearly not prime. It's divisible by 3, and that's the message we get on screen. If you manage to successfully get through the last program, you might find this next programming problem fairly simple. Here we are going to try and remove duplicates from a list. This can be a list of numbers, a list of strings, any kind of list. We do not want to modify the original list though. We want to create a brand new list with no duplicates. And let's not use the shortcut where we add all the elements of a list into a set and then get a list from that set. We'll actually write code for the logic of removing duplicates. Here is a hint that will help you solve this problem. We are going to iterate over all the elements of a list. This is where you'll use a for loop. We've created a new list which contains only unique elements. Before you add a new element to this unique elements list, make sure the element isn't already present in there. Here is a list of names, and some of the names are present twice. You can see that Atara and Abhay are present more than once in this list. We want to remove those duplicates. Instantiate a new empty list that will hold our unique names. We'll now iterate over the original list. For every name in our list of duplicates, the first thing we'll do is to check whether that name is already present in the unique list. If yes, we continue. Continue means we go to the beginning of the next iteration. We will not execute the commands which come after this if statement. If the unique list doesn't already contain the name, we will append this name to that list and then print out the unique list at the very end. And when you execute this bit of code, you'll get the list of unique names: Deb, Athira, Abhay, and Viren. Next programming challenge has to do with sorting. Now we won't work with any of the advanced sort methods. Here we'll perform a very simple sort where we take in a list of numbers and create a new list with those numbers in sorted order. Don't worry about trying to implement any advanced sort algorithms. We are going to do the very basic sort. We'll iterate over our original list multiple times. At every step, we'll find the smallest number that is present in that list, remove that number from the original list, and append it to the new sorted list. We'll first initialize the original list, the unsorted list of numbers. This contains integers in any order. And we initialize a new empty list which contains our sorted list. We've seen only one example of using nested loops so far. Here is another. Here we'll have an outer while loop. This outer while loop is responsible for creating the sorted list by appending the min value at every step. Within this outer while loop, we have an inner for loop, which basically finds the min value from the original unsorted list. We start off by assuming that the min value is the first element in the unsorted list. Then we iterate over the unsorted list to find what the actual min value is. We've seen this program before. Once we've found the minimum value, we will remove this from the unsorted list using the remove function, and we will add this minimum value to the sorted list. We'll append at the very end. We'll work through this with an example so that you really follow. Notice the outer while loop. The while loop goes through as long as we have some elements left in the unsorted list when the length of the unsorted list is greater than 0. At the beginning of the first iteration of the while loop, the unsorted list, let's say, contains the elements 4, 1, 3, 2. The sorted list is completely empty. Our aim is to fill up the sorted list in the right order and completely empty the unsorted list. Our inner for loop will find the minimum value that exists in the unsorted list. I won't go into the details of how this minimum value is found. We've already studied that in great detail earlier in this course. Minimum value in the unsorted list is 1. This is the value that will be removed using unsorted list dot remove, and this minimum value will be appended to the sorted list. At the beginning of the second while loop iteration, our unsorted list has 4, 3, and 2. Our sorted list has 1. The length of the unsorted list is greater than 0. So we go through the while again. We find the minimum value in the unsorted list, which is 2. We remove it from the unsorted list and append it to our sorted list. When we go back to the beginning of the while loop, our unsorted list contains only the elements 4 and 3. Sorted list contains 1 and 2 in sorted order. Once again, we find the minimum in the unsorted list, which is the number 3. Remove it from the unsorted list, add it to the sorted list. Our unsorted list now contains one last element. 4. Our sorted list contains 1, 2, 3 in sorted order. We'll remove this last element from the unsorted list, add it to the sorted list, and our sorting is now complete. At this point in time, our unsorted list is now empty. Its length is 0. Our sorted list is full. It has all the original numbers in sorted order. This is when our while loop condition is finally false. The length of our unsorted list is equal to 0, not greater than 0. We break out of the while loop and we have our sorted list, as you can see on screen. For our next programming challenge, we'll write a program which swaps the positions of two elements within any list. Let's say our original list was A, B, C, and D, and we wanted to swap the positions of the elements A and D. We want our program to modify the original list such that the list is now D, B, C, A. The hint here is very straightforward. Whenever you perform any kind of swapping operation, make sure you use an extra variable which will store one of the values being swapped. Let's work with the list of tech companies. We have this Google, Apple, Microsoft, Tableau, and Intel in one list. The index positions where we want to swap the elements are 1 and 3. We'll store this in variables I and j. We want to swap the element at index 1, that is Apple, with the element at index 3, that is Tableau. Anytime you're swapping stuff, you'll typically need to use a third temporary variable. So in the variable temp, we'll first store the element that is present at the ith position in the list. So assign the element at the ith position to temp. The next line of code will then assign the element which is at position j to the position I. Tech companies of I is equal to tech companies of j. This will overwrite the element that was present at index I, but we don't have to worry here. We've already stored that element in our temp variable. And then finally, at the last step, at position j, we will write the value of temp. Remember, the value in the temp variable was originally at position I. Once we've completed the swap, we can print out the list and notice in our result that the positions of Tableau and Apple have been swapped. Tableau is now at index 1, Apple is now at index 3. Here is another programming challenge for you. Given an integer which the user inputs on the console, extract the number that is present in the tens place of that integer. If you do not remember your place values, here is an example. For the integer 1, 2, 3, 4, the number in the tens place is the number 4. Here is a hint that you may need to solve this problem. Now, to extract the number in the tens place from any integer, you need to find the remainder that you get after you divide the number by 10. Let's take the original example 1, 2, 3, 4. If you divide that number by 10, the remainder that you get is 4. That is the number in the tens place. You can consider a simple example. Let's consider the number 13. If you divide 13 by 10, the remainder that you get is 3, and that is the digit in the tens place. With this hint, the program itself is very simple. You simply accept an integer input from the user, make sure you convert it to an int, and then you use the modulo operator to find the remainder when that number is divided by 10. The modulo operator directly gives you the remainder, so that's very convenient. That is the digit in the tens place. Let's execute this little program. We have the number 12564 and the number in the tens place is 4. And here is our next programming problem. Given an integer that the user has input, we want to extract every digit from that integer and store those digits in a separate list. For example, if the user input 1, 2, 3, 4, we want a list which contains the elements 1, 2, 3, and 4 in any order. Solving this problem requires a teeny bit of mathematics, and such problems are very common when you're working with analyst or programming interviews. They want to see how you can combine a little bit of mathematics with logic. This problem statement builds on what we've learned before. We know how to use the modulo operator to divide a number by 10 and extract the digit in the tens place. Now, if we divide the original number by 10, the number that was originally in the hundreds place will shift over to be in the tens place. You can then extract the digit in the tens place once again using the modulo 10 operator. This is a little tricky. See if you can work it out on pen and paper before you start coding. Here is the user input. We store the integer in the num variable as before. We'll initialize a new empty list, the digit list, which will hold our list of digits. And here is the core logic of the program. There is a lot going on in this 3-4 lines of code. Let's work through it with an example. Let's say the original number was 214. We want to extract the individual digits so that we get a list which contains 1, 2, and 4 in any order. Let's start off by considering the very first iteration of the while loop. Num is equal to 214. That's clearly greater than 0, which is why we enter the while loop in the first place. At the beginning of the first iteration, num is equal to 214 and the digit list is empty. We extract the digit in the tens place by using the modulo operator. That's the first statement in the while loop. We find num modulo 10, that will give us 4. Digit will hold 4. Once we've extracted the digit 4, we append it to our digit list. So at the end of the first iteration, digit list will be equal to 4. Now the next statement in the while loop is the interesting one. We divide num by 10. This is an integral division. That's why there is the double forward slash, and store the result in num itself. 214 divided by 10 is equal to 21 if we do not consider the remainder. 21 is what num holds at end of iteration 1. To help us debug this, we print out the value of num for every while iteration. At the beginning of the next iteration, the value of num is equal to 21 and digit list contains the digit 4. Now we extract the number in the tens place from num, which is the digit 1. We append this digit to the digit list so that our digit list is now 4, 1. We then divide num by 10. We are only interested in the quotient. 21 divided by 10 will give us 2. At the start of the third iteration, the num variable holds 2, the digit list holds 4, 1. We now extract the digit that is in the tens place by finding the modulo of num by 10. We extract 2. That's what is stored in the variable digit. We append that to the digit list so that the digit list is now 4, comma 1, comma 2. The next statement then divides the value of num by 10. We are only interested in the quotient, and now finally the quotient is equal to 0. Now, when we go back to the beginning of the while loop, num is equal to 0 and digit list contains 4, comma 1, comma 2. The while condition evaluates to false because num is no longer greater than 0, and we break out of the loop. Execute this code to see if it works as we expect. I enter the number 2355 and I get the result. The digit list is 5, comma 5, comma 3, comma 2. Notice the value of num at every step. It really helps in debugging if you print this out. The num value started off at 2355, then became 235, then 23, and then 2. Till finally, when the value of num was 0, we broke out of the loop. Here is your next programming challenge. Given an integer, you need to reverse the digits of that integer. Let's say the user input 1, 2, 3, 4. You need to generate the number 4, 3, 2, 1. Now, there are several different solutions to this problem, as is the case for any problem that we've seen so far. One very simple way to do this would be simply to convert the integer to a string, reverse the string, and reconstruct an integer from the reversed string. That's kind of cheating though. We'll try to do it the mathematical way. We know a bunch of stuff for this problem already. We know how to extract the digits in the tens place of a number, and we know how to extract the individual digits of every number. Here, after every extraction, we'll use that digit to reconstruct the reverse number. First, we'll accept an integer as input from the user. We'll convert the user input to an integer and we'll initialize the reverse number to 0. And here is the code that performs this operation. There are just a few lines of code, but there is a lot going on here. Let's start at the beginning. Num is the variable which holds the original input. Let's work with an example so that you can see how things change for every loop iteration. We'll work with the example 214. The end result we want is 412, a number with all digits reversed. And this number 412 should be stored in the reversed num variable. Let's start off at the beginning of the first iteration of the while loop. We enter the while loop because the value of num is 214. This is definitely greater than 0. When we enter the while loop for the first time, the value of reversed underscore num is equal to 0. Now the first statement in the while loop extracts the digit in the tens place. Digit now has the value of 4. Executing the next statement will multiply the current value of reverse number by 10. Reverse number is 0. 0 multiplied by 10 is equal to 0. In the next statement, we now add digit to our current value of a reversed number, which means 0 plus 4 will give us 4. We then divide our num value by 10. 214 now becomes 21. We are only interested in the quotient. This we do to extract individual numbers from our num variable. We are now once again at the beginning of the while loop. We check the while condition. Num is equal to 21 at this point in time. 21 is greater than 0. So we enter the while loop once again. The value in reversed num is currently equal to 4. This is at the beginning of the second iteration. Now the first statement extracts the next digit from the num variable. Digit will be equal to 1. 21 modulo 10 is equal to 1. We then multiply the current value of a reversed number by 10. The current value is 4. 4 multiplied by 10 is equal to 40. Once we have 40, we add the currently extracted digit to reversed number, giving us 40 plus 1 is equal to 41. Once again, we divide number by 10 to extract the next digit. 21 divided by 10, we are only interested in the quotient, gives us a value of 2, which is assigned to num. Because we keep multiplying the reverse number by 10, the value in reverse number keeps increasing and getting the digits that we extract from num. Because we divide num by 10, the value in the num variable keeps reducing. Now, when we go back into our while loop iteration, the value of the num variable is equal to 2 and reversed num is equal to 41. Notice the partial reversal that has taken place. The very first statement within our while loop, digit will extract the last digit from the num variable, which is 2. We then multiply reversed number by 10, which will give us 410. Reverse number then gets digit added to it, giving us 412. The num variable now once again we divide by 10. This gives us a value of 0. Once num reaches the value of 0, we'll break out of this while loop, and at this point the reverse num variable contains a final answer, 412. Now, if you didn't really follow what was going on, I suggest you go over this again. This is a hard problem, but this goes to the heart of programming logic. This kind of logic is what will really be useful for you when you go out into the world looking for jobs, not just as a programming interviews problem, but in general as well. In order to help us debug and understand the progression of this program, at every step we'll print out the value of the reversed number and the value of the number. And finally, when we exit from the loop, we'll print out the final reversed number. Go ahead and hit Shift Enter to execute this program. The number we input is 2345, and here is the reversed number. The answer is 5432. This is the reverse number. Notice at every step, we get one digit extracted from the original, put it into the reversed number, and shift that digit left. Notice the progression of the reversed num variable. It started off with a value of 5, then became 5 and 4. 5 was shifted left and 4 was added. Then it became 5, 4, 3. 5, 4 was shifted left and then 3 added. Then it became 5, 4, 3, 2. 5, 4, 3 was shifted left and 2 added. This shift left operation is performed by multiplying the reverse number by 10 on every iteration. As a corollary, notice the progression of the num variable. Originally, num was 2345. Then we divided by 10, it became 234, 232, and then 0. Dividing a number by 10 is the operation that helps us drop the rightmost digit.